Hi everybody, welcome back to the Professor's Du Bois channel. Today we're going to be talking about ionic compounds and how to name them. We better get started because there's a lot to cover.
A lot of material here.
Yeah,
Let's
you
get
ready?
started.
Okay.
All right, binary ionic compounds. So binary, like a bicycle, binary means we have two. We're going to have two different elements. So what makes an ionic compound different than a covalent compound? There's a couple things to look for, but what it really amounts to is an ionic compound has ions. So we have an actual loss or gain of electrons forming ions, and then these ions with their opposite charges are attracted to each other, and we call this an electrostatic force of attraction. That's the bond. So how do we know if it's an ionic compound? Here's a pro tip. It's super easy. We want to make this easy for you. Look for a metal, right? We said the molecular compounds or the covalent compounds are just nonmetals. Well, you're going to realize that these ionic compounds often, mostly, have a metal involved with them. We can tell if there's a metal just from looking at our periodic table. We know where the metals reside on the periodic table. Now, when these ions form and combine and form a compound, it's much like the network covalent compound. Remember how diamond would form this crystal lattice? Well, that's how all ionic compounds form. So when we write an ionic compound, like the example at the bottom is CaCl2, that's an empirical formula. An actual calcium chloride crystal has lots of calciums and lots of chlorides, but they're in that 2-to-1 ratio. So we represent ionic compounds is an empirical formula. Now it gets a little bit tricky because we have to make this neutral. This compound, it's not an ion, it's a compound. So we have to combine these such that the charges cancel. So with the chlorine, I have a -1 charge, and we just represent that with a minus. We don't write the 1. Calcium has a 2+ charge. And you want to write +2, but technically you should write 2+, 3+. It's just one of those funny things, but it's okay either way. We won't make fun of you. So since I have 2 pluses, I need 2 of those chlorines to get 2 minuses to make the net or the resulting compound neutral, CaCl2.
And you're going to want to be using your chart of your common ions to get started here. So if you have to put these together, we had the calcium chloride. You could look here. Calcium was a +2 and the chlorine was a -1. Just take special note of these polyvalent ions as well, because they can have more than one. We're going to talk about that in a moment. But you want to be able to go from the different types of compounds, or the elements that are being combined. You have to be able to make that formula and make it neutral. So once you have an ionic compound, you have to be able to name it, or from a name you have to go back to the formula for that compound. And when you name ionic compounds, the cation or the metal goes first, and it's just the name of that element when we're talking about a binary ionic compound. If there's more than one possible charge, this is our polyvalent, where there's 5 of them that you need to know, and we indicate which charge it is by a Roman numeral. So iron, if you go back to our list here, iron can be an iron +2 or 3, and when we write that and name it, we have to use a Roman numeral. So this is an iron 2, and it's also combined with chlorine. So chlorine is a -1, and if our iron is a +2, we need 2 of them. The anion, when you're writing your name, it goes last, and just like for the molecular compounds, we change the N to IDE. So for NaCl, Na is just sodium, and then we change the last bit to chloride instead of chlorine.
No prefixes with ionic compounds.
Oh, thank goodness.
So here's just some examples. Like we can write a formula and then name these compounds. So again, it'd be useful to have that chart handy with the common ions. But if I looked at that, I would see my sodium ion is the +1, and the fluoride is -1. So I can just combine these together and they'll be neutral. There's 1 +, 1 minus. So the formula is just NaF, no subscripts, and this is named remember we named we always put the metal first, or the cation, the positive ion, cation. So that's sodium, we just say the name. The fluorine, we drop the ending, add the IDE, sodium fluoride.
The next two examples have oxygen, combining with two different things combining with oxygen. Oxygen creates a -2 charge, and barium +2, and sodium just 1, +1. So when we combine the barium oxide, it's +2 and -2, so just a 1-to-1 ratio makes it neutral. Barium is the metal, we just say its name, and the non-metal, we change the N to IDE, barium oxide. But for sodium, we have a +1. We need 2 of them to balance and cancel out that -2. So we have a subscript here that signifies that there's 2 atoms of sodium for every 1 atom of oxygen, sodium oxide.
So in these two examples, we've got cations, or metals, that have a 2+ charge. So the copper is a 2+, and the barium is a 2+. The barium is combined with fluorine, which is a -1 charge. So we need 2 fluorines to make this a neutral compound. And this is named simply barium. That's the name of the metal. And then we drop the suffix and add the IDE. Fluorine becomes fluoride. Now the copper is a little more complicated. We have to combine these in a ratio such that we make a neutral compound. So we'll need 3 coppers, each with a 2+ charge. That would be a total of 6+, and 2 nitrogens, each with a 3- charge, for a total of -6. Now the other thing is copper is one of those polyvalent metals, so we have to write with a Roman numeral that was the copper 2+, because there's another copper that's just +1.
Yep, and that's right here. So we have copper can be just the +1 or +2. Polyvalent means we need the Roman numeral. All right, so that was a little bit tricky, trying to figure out, how to combine those. So this is a little bit of
Pro tip.
Here's a pro tip. You can use drop-in switch. So you can make the charge on one of these the subscript, or the number of atoms of the other. And you do it for both. So here's an example. We have aluminum, and that has a +3 charge, and an oxygen with a -2. So if I take the charge on the aluminum, 3, and I say, okay, 3 oxygen atoms. The charge on the oxygen is 2. I'm going to say 2 aluminum atoms, and that then gives you a neutral compound. So we have 2 3s, that's a +6. We have 3 -2s, that's a -6. And that's our aluminum oxide. You do have to be careful because you have to reduce to lowest terms. Now, if I do a drop and switch over here with the barium and the sulfide, then I have Ba2S2. And remember, these are empirical formulas, so that would be reduced to just BaS. And that would be barium sulfide. And similarly, we get 1 and 3 here for the indium bromide.
And just note that we don't write the 1, so we don't write a subscript 1. You could write a 1. We probably wouldn't beat you up too much for it, but
it's not right.
It's not technically correct.
Not technically right.
Polyatomic ions are interesting. Now, we know they're ions because we'll see a charge. You're going to see a charge in the upper right. It's going to be positive or negative. It could be just a positive. It could be 2+. But these polyatomic ions, poly, many, atomic, atoms. So these get kind of cumbersome, but they're really, really simple. And we'll show you how to handle these. So an example, I know these are really hard to see, but this is a list of common polyatomic ions. And we wrote one out. It's the NH4+ ion. So this is nitrogen with 4 hydrogens, and it has a charge. Now notice the elements involved in polyatomic ions are all nonmetals. So they're covalently bonded, but they're in such a way that they end up with a charge. And let's just keep it simple like that for now. So the neat thing about polyatomic ions is the name is on the chart, and we just use the name from the chart. We don't drop the suffix or nothing fancy with these. So they're actually pretty good to memorize, saves a lot of time, but you'll have a chart at your disposal.
So for writing formulas with polyatomic ions, so if you are given these polyatomic ions and you have to combine them in a formula, you're going to use the same concept that you have to have electrical neutrality, or the charges have to cancel out. So if we were going to combine these two, this +1 and a -1, it's just a 1-to-1 ratio, and you would write the cation first, just like with the binary. You write the cation first, the positive one first, and then the negative one. And the naming, super easy. It's just the name of the different polyatomic ions. This is the ammonium ion with the chloride ion, ammonium chlorate.
So in this case, two polyatomic ions combine to make a compound.
Correct.
Ionic compound.
So here's the next one. If you do your drop and switch, you have 3 of these dichromate ions, and you have 2 iron 3 ions. So iron is polyvalent, so we need the Roman numeral. So this is an iron 3 with the dichromate ion.
And also note those parentheses around that dichromate ion, because we needed 3 of that entire ion. We'll put parentheses around the ion with a little subscript 3.
Right.
Now, if there's only 1, like in the first example, no parentheses are needed.
Yeah, so this actually means that there are 3 of these, so there are 6 chromium atoms. And moving on, to make this neutral, I need 3 of these ammonium ions to cancel out 1 nitrogen ion, or the nitride ion. So I need the parentheses to indicate that there are 3 of these ammonium ions to 1 nitrogen ion, ammonium nitride.
Now, yeah, we're back to nitrogen, which is just an element. So in this case, we did have to drop the suffix for nitrogen and add the IDE.
Correct. Yeah, good point. This is the copper 2 ion, +2 instead of just +1, combined with the sulfate ion, 1-to-1 ratio. We don't need parentheses. Copper 2 sulfate.
We did have to put that 2, Roman numeral 2 in parentheses, because that's a polyvalent ion, and we need to know if that's the copper 2 or the copper 1.
Okay, this is a little bit tricky. Mercury, this Hg2 +2. So mercury can just make a +2 ion, or it can be a polyatomic ion with itself. So it's covalently bonded, these 2 atoms of mercury. Both of them have a +1 charge for a collective +2 charge. But what's interesting is that since each of these mercury atoms only have a +1 charge, its name is mercury 1. And the other one is just 1 Hg atom, and it's a +2 charge. That's mercury 2. So when you're combining mercury 1 with oxygen, we have a +2 with a -2, 1-to-1 ratio, but this is a polyatomic ion with 2 mercury atoms. So we have Hg2O.
Oof.
Oh.
That one hurt.
Oof.
So we can go the other way. We can write the formula if we're given the name. So iron Roman numeral 3, that means iron with the +3 charge. Nitrate, notice the ATE, not an IDE. That just screams, I'm a polyatomic ion. Go to the chart, sure enough, there it is. It's got a -1 charge. So in order to combine these and make them neutral, I'll need 3 of the nitrates. I'll have to put the parentheses in with the subscript 3. Couple more examples for you to see. Got another polyatomic there with the ammonium phosphide. Zinc fluoride, we need 2 fluorines. And wait, look at this one. This is a molecular compound.
Threw that in there just to bring it back.
Oh, you're making me crazy. This is supposed to be ionic compounds. Notice the prefixes that jumped right out at me. I said, one of these is not like the other. So dinitrogen pentoxide, that's a little flashback to the previous lecture of the covalent compounds, N2O5.
All right, here's the summary. I would just pause the video and take a look at this. This summarizes everything that we just went over. And we want to give you some practice. So go ahead and name the following ionic compounds and then go from the name to the formula. So pause the video and try that. We're going to give you the answers. There's your answers. Hopefully you did well.
Thanks so much for hanging in there with us, you guys. Hopefully that was useful. A little practice goes a long, long way. Thanks again for watching the Professor's Du Bois.
Bye bye.